Ian, again, good morning or good afternoon, depending upon where you are in the country. And welcome to today's webinar on basic standalone PV system troubleshooting. My name is Rob Rallo. I'm a senior engineer at SunWize. And today's topic, again, is going to be about how to get started with your system troubleshooting. And I hope everybody had a good eclipse on Monday. And I hope your solar system survived. If it did not, hopefully this webinar will help you. A couple other reminders. Please place your questions in the box. We'll try to get to those at the end as we have time. And also, as always, our webinars are recorded and will be available on our website within 24 hours after we're done. Some of you may already know this, but for those who don't, just to give you a little brief description on SunWize. SunWize is a company focused on off-grid power solutions. Have over 20 plus years of experience in that. Myself, I've been in the off-grid solar business for over 25 years now. Some of the solutions are hybrid, standalone, UPS systems, things like that. We have warehouses in a few locations in the U.S., including Oregon, California, and New York, and we have sales offices all over the country. Again, we focus on off-grid systems, hybrids, standalone, CDC, which is also known as a cycle charge, UPS systems, battery backups, and we're also a distributor of components as well, so we can provide both power solutions and component solutions if you need those. Some of our other services include design and engineering. We can help with technical specification writing. Actually, I was helping out somebody with that just last week. We can do training, similar to what we're doing right now. Installation services, site surveys, and other services associated with off-grid systems. Okay, so today we're going to start with normal maintenance. Then we're going to talk a little bit about how you know if your battery is healthy or not. And then we're going to get into the troubleshooting, which should start with the controller. And then we're going to talk about why that is. And then we're going to do a brief review of last month's webinar on, or actually earlier this month's webinar on array troubleshooting. So we're going to review that webinar briefly and go through that because that's another big part of the system troubleshooting is troubleshooting the array. So we'll review that. And then we'll talk about some load conditioning equipment, which might be a DC-DC converter or an inverter, and how you know whether those are working correctly or not, whether those are the problem or whether it's something else in the system. So we'll try to cover all of these things in today's presentation. So let's just quickly review some of the components that are in a off-grid system. You've got solar modules, solar mounts, which is the structure, your charger, battery, and typically an enclosure, and sometimes you might have power electronics. Again, that would be your power conditioning equipment like a inverter or a DC-DC converter. And what we're going to try to do today is we're going to try to figure out which part of the system is your issue and how do you correct it. So we're going to start, so one of the first things to do is to try to isolate the problem, and then you can address that component once you figure out which one it is. I find it interesting that almost 90% of the calls I get are my charge controller have gone bad, yet the charge controller is not the problem. So that's one of the reasons we want to start with the charge controller because, again, a lot of the tech support calls I get are for a new charge controller when that's not the issue. So we want to get into why that is, what the problems might be, how to address it, and how to fix it. So one of the things you're going to need for troubleshooting, and for maintenance, by the way, is going to be just some basic tools. Multimeter. Probably the most important tool is your multimeter. I can't stress that enough, and it's worth spending the money on a good quality one. I've had a Fluke 87 meter now for over 20 years. I've actually got one of the original ones, the Series 1. I think they're up to like Series 4 or 5 now, and mine is still working wonderfully. So a good multimeter is absolutely essential for any good field work, whether it's maintenance, installation, or troubleshooting. Very important tools to have. Insulated screwdrivers, other basic tool to have for tightening terminals, checking them, especially for maintenance. We're going to get into that, but it's important to check your connections, make certain they're tight. So screwdrivers are important for that. Insulated ones are also good, so you don't actually come in contact with something else and short it out. And obviously wrenches for making certain battery terminals are tight, and other components like your structure as well. Other things that might be handy might be wire cutters or strippers, depending on if you have to repair any wire connections or not. And along with that, possibly some extra wire in case you do have to make some repairs if you have a corroded connection or something like that. Electrical tape, also handy for taping off connections, especially if you're trying to do some isolation by disconnecting a solar array. If you don't have circuit breakers for that, you may have to remove the wires. You may want to tape those off to prevent shorting or something like that. So electrical tape can be very useful for troubleshooting. Fresh batteries or a portable battery charger can also come in handy if your battery is already low state of charge. So having to swap out the batteries to help with troubleshooting or being able to recharge those on site may also be handy. And then sometimes having some additional circuit breakers, DC rated ones, preferably 150 volts, are also can be handy for troubleshooting. Okay, as I mentioned, you should maintenance, and it's very important to go through that first. You'd be surprised at just how many problems you can prevent and find just by doing some basic standard maintenance. So we're going to start with that first. And the other thing I want to start with is that maintenance should be done approximately every 6 months to a year, definitely annually, generally twice a year. We usually recommend in the spring and the fall. The reason for that is usually coming out of the winter, you might have some problems. And then going into winter, you want to make certain your system is good. So those are two good times to do maintenance. Okay. Okay. And again, some of the things you can look for, we're going to get into some more detail, but look for just any issues with wiring and even some problems with vegetation growth at the sites and things like that. So again, because of that, we're going to start with the visual inspection, which you're going to be looking for shading from the solar array. You know, a lot of times you're going to have vegetation that has grown up that wasn't there before. Stuff can grow very quickly. So you may have installed the system and worked great for a couple of years, and all of a sudden it's not working because a tree has grown up in front of it, or some other type of vegetation, a bush or grasses have grown too high or whatever. So it's important to look for that. A damaged solar module, that could be damaged, either something has hit it, that could be vandalism, it could have been hail, that maybe has broken the front glass, or the back of it may have gotten damaged somehow by wildlife. We frequently hear about rodents gnawing on the back of them as well. So that's just something you want to check for and either repair or replace. You want to check your circuit breakers, make certain that they are all good and functioning well. And wiring, I mentioned that before. You want to definitely check for corrosion. Make certain all the connections are tight. That's where the screwdriver comes in handy, especially if you have a junction box in the back of a solar module. People always ask, why do you have to check for the determinations? If they're tight, they're tight. But what ends up happening is that thermal cycling causes them to loosen over time. You know, as metal expands and contracts, which happens through normal cycles, depending on where you are in the country, you might find the temperature varies by 20 degrees a day or 30 degrees a day or even more. And that delta in temperature causes the metal to heat up and then shrink and heat up and shrink and heat up and shrink. Although it may not seem like much, over the course of years, that can be enough to loosen a connection, and it can cause all kinds of issues at that point. I pointed out the solar module junction box because typically the solar modules run hotter, so you'll find that they'll vary by even more than 30 degrees a day. They can vary by 40 or 50 degrees. So because of the fact that temperature swings on the solar module, because they heat up in the sunlight, can cause those connections to loosen faster than the other ones. So again, it's important to make sure that all those connections are tight. And again, of course, corrosion, and make certain your wires are not chafed or damaged. Again, if you've got cables external, generally, as an example, the array output cables are a common one, where they could get gnawed on, again, by a potential rodent. They like to take the insulation off of it and use it as a nesting material. that could be a problem, or it could have maybe been chafing through wind against a pole or against the structure or something else like that. So just make sure there's no damage to it from chafing or something like that. Just a couple examples of things you can find during inspection. Here's one where you can see in a cornfield where the corn has been planted and grown up around the solar modules, and therefore they do not work correctly because the corn is now shading it. And let's see, and I'm going to skip to this one real fast. This is another one that was found where the wire actually got corroded. Here's an example of the wire, the insulation got chafed, and then the copper wire that was exposed. Again, now if this would have been caught in maintenance, if somebody would have noticed that the wire was chafed, it could have been repaired either with some heat shrink or electrical tape or something else, or even replaced before the system failed. But what had happened was it wasn't, and therefore the copper wire under the insulation that got exposed corroded, and corroded enough that it actually caused the wire to break and separate, disconnecting the solar module from the system and thereby causing the system to fail. So again, this is why it's so important to do these inspections to prevent things like this from happening. And when they do happen, you can find them easily as well just by doing the visual inspection and maintenance. Okay, just again, highlighting some things I said before, you're looking for loose wires or connections and corrosion. Thermal cycling can cause those things to happen. Corrosion, I know I was just showing you one on the outside, but again, corrosion around battery terminals is also very common as well. If the batteries do gas at all, the battery gas can be corrosive, so you'll find that a lot of the battery terminals are ones that also corrode. So again, check those. Also check those for tightness. Those are also ones that loosen quite a bit. Again, because of thermal cycling with the batteries and just the fact it's hard to get a tight connections on those, so always check those as well. And crimps, that's another one. Your crimps, if you have crimps on your battery terminals or on other terminals with compression lugs like that, you just want to double check that there's no loose connections there as well. Same thing going on. You can have looseness over time or things like that. So just something else to check with your mechanical inspection. Grounding, another one that's very important. Actually, we're about to release a new tech note on grounding, just because they can be a problem as well. And again, what you're looking for there is corrosion, something that will be preventing a good ground. You also want to check for loose connections again. Same thing, you got thermal cycling going on. These are all things that can be checked and corrected on a regular maintenance schedule. And you also want to confirm that you have no resistance. If that resistance is low, less than 0.5 ohms, this is where your multimeter can come in handy as well. You can set it to resistive measurements, and then you can check that, make certain it's less than 0.5 ohms. Now, that's not with respect to earth ground. That's just between the grounding system. So somewhere between your battery negative terminal or positive on a positive ground system and your ground rod or your ground system, you want to confirm that it's less than that. If it's more than that, you want to check and see where that resistance is. If you've got a loose connection or a corroded connection somewhere, that's going to cause that resistance to be higher. So one of the easy ways to just double check that is just pulling out your multimeter, checking the resistance, confirming that it's low and that there's no spots that need to get corrected. I don't think we're going to talk about that in this webinar too much. Maybe I'll talk about that in a tech note or future webinars. But it's important to have a good ground because that really helps with transients. If you get some type of surge, a voltage transient, and you don't have a good ground, that could damage your equipment. So this is a good preventative thing with regards to maintenance, where if you're checking that, making sure that ground is good, giving a path to ground for any surges you might get from transients that get voltage transients that can occur from a nearby lightning strike. To be honest, if your system takes a direct lightning strike, there's not much you can do. But if you have a nearby strike, it can induce a voltage on a wire. Matter of fact, any wire that is outside of your battery box that's more than 5 feet can have a voltage induced on it by lightning that's a mile or 2 miles away. By giving that voltage a path to ground, it helps that. Now, these would typically be through your surge resistors that are in your charge controllers, your transformers, resistors, and things like that. But again, if you have a bad ground, there's no place for energy to go, and it will end up damaging your charge controllers and things like that. So very important. Okay, moving on to batteries. One of the other questions that get asked a lot is, how do you know if your batteries are healthy? And sadly, there really is no good or easy answer to this question. and I'm going to try to give you the best solutions, but again, there really is no easy one. The most common one is, the way to know if your batteries are good or not, is when they actually fail. They can no longer hold the charge. So basically what will happen is that all of a sudden you'll see your voltage, your battery voltage flying up quickly and then dropping quickly. So when it's under charge, you may see it jump from, for a 12-volt battery, it might jump from 12 volts to 14 volts, and as soon as you take the charge off, you'll watch it drop back down to 12 volts again. So if you see your battery doing that quickly, within a matter of minutes, there's a good chance that you've got a bad battery. So, but again, unfortunately, at that point, that's when your battery's pretty much completely failed, and your system may have failed because of it. So unfortunately, that's not what people want to hear, but if it comes to that point, your batteries are already in really bad shape, and your system's probably failing because of it. So hopefully you can try to find it before it happens, but again, this is not an easy thing to do. One of the best ways to look for it before it happens is to look at the history, look for trending. And this can be done by recording your battery voltages. Again, one of the things that should be done during standard maintenance is record the voltages and then look at those. If you got a charge controller with data logging, that's another good way to look at it. If you can download that during a maintenance cycle, even if you don't have remote access to it, a lot of our newer ones have remote access via serial ports and Ethernet connections and things like that. But even if you don't have that, you can still, a lot of the charge controllers have data storage on board that allows you to plug in with a portable computer and download that data, and then you can analyze it back at the office later. So if you have that capability, you might want to think about perhaps adding a portable computer, a laptop, to your list of tools that can help you in maintenance at trying to look at trends on the system. One of the things you want to look for is your battery getting fully charged? A lot of the controllers will tell you if it reached absorption on the charge cycle. If it has, it's a good thing. If you haven't reached absorption in several weeks, that's not a good thing. That means your battery's not reaching full charge, which means it could sulfate, and you could be looking at a shortened life of the battery. So you can look at that, you can look at the voltages to see whether it is holding a charge before it actually gets to the point where it completely fails. So if you have that capability, that's a good thing to do. Actually, we have a little handout on our handouts list. One of the handouts is how to get the data out of the charge controller. So if you've got a Morningstar product, we have a little handout on that, as well as some additional handouts on troubleshooting that could be handy as well for you to look back and review after this webinar. Okay, the other way to know if your batteries are healthy or not is with an impedance meter. These things are very expensive. I mean, on the order of thousands of dollars. They range anywhere from like $1,000 to $5,000, depending upon the meter. So they're not cheap. Not only expensive, they can only be used in certain circumstances. And the key there is you have to have a baseline number. These things measure an impedance in the battery. They're great because you can get a number really fast, and they can be done with the batteries online. So you don't have to take anything offline. You don't have to turn off the charge. You don't have to disconnect the load. You don't have to do anything to them. You can just put this meter on them like you would a voltmeter and measure the battery terminals, and it spits out a number. The thing is that it's worthless without a baseline number. And so unless you've got a baseline number from a brand new set of batteries you just installed, or you have that information from the battery manufacturer on that specific meter, because each meter measures that differently. They have a different number. It's measuring capacitance and inductance and all the things in the battery, resistance in it and things like that spits out a number, but different manufacturers do it in a different way. And it's different for different battery technologies. So you have to have that number on that specific battery number, so it's a battery model with that specific model of impedance meter. So if you don't have that and you don't have a baseline for measuring it, then it's worthless. It's not going to tell you anything. So there's a whole lot of caveats to that. So it's an expensive device, and without those baseline numbers, it's worthless. But if you have that, it's a really handy way to find out really fast the health of your battery. The only other good method for that is a capacity test, and this is not easy to do on a standalone system. If you've got a UPS system or some other type of system with a generator or something like that, then it's an easier test to do, because what you have to do is you have to start with the battery at a full state of charge. So the battery has to be fully charged to begin with. Then you have to put a constant or specific load on it. Now, if you already have a constant load, that could be as easy as perhaps just turning off the charge to it, the solar array or whatever it is, and then letting it discharge for a specific period of time, and then measuring the batteries along the way to figure out what the capacity is by measuring the voltages. And then based upon that, you can figure out what the battery capacity is to figure out whether the battery is still at 100% capacity or 80% capacity, where it is to figure out when it needs to be replaced or not. A general rule of thumb is if your battery is only at 80% capacity, so an example, if you've got a 100 amp hour battery when it's brand new and now it's only holding 80% of its capacity, then it might be time to replace that battery. But again, the only way to confirm that is with the capacity test, really. The other problem with this is, again, when you've done this, you drain the battery down and then it has to be recharged. So again, this is not something you want to do on a standalone system because first off, it's difficult to get a fully charged battery because it's being cycled constantly. And then after that, you have to either recharge it again. So again, this is not easy to do with the system in the field on a standalone one. Again, if you've got a generator there, then you can use that to charge your batteries at the beginning of the test and at the end of the test. If you've got a UPS system, again, it's the same thing, just turn it back on. The only other way to do this is perhaps take the batteries out of the system to come out there with a spare set of batteries and install those, take these out, take them back to the lab or the office, the bench, whatever you have, bench test them, and confirm their capacity, and then perhaps put them in another system and just rotate your batteries that way. That might be a way to do that. But again, this is not easy to do out in the field on a standalone system. So again, there's really no easy answer to this one. I get this all the time. You know, it's just that's sadly there's just not an easy solution. So those are the three solutions you have: is, you know, wait for them to die, or to try to get some history on them, some trending, if you can get that out of the data loggers. Get an expensive impedance meter and have a baseline for it, or do a capacity test. If you want more information on capacity tests, most battery manufacturers have details on those as well, by the way. So if you contact battery manufacturer or us, contact SunWize with the batteries you have, and we'd be happy to get you the capacity test recommended by the manufacturer on that. And again, in addition to the handouts, you can always go to our website for additional information on troubleshooting with regards to shading, module testing, things like that. So again, always go to our website. We have a whole bunch of tech notes we're coming out with. I've written a whole bunch lately, so there'll be a whole bunch more going up there in the next couple of weeks. So always keep checking our website for the latest and greatest and some new stuff. You might find something new up there you didn't know about, a topic you hadn't really thought about. So keep checking that to look for some of the latest information there. Okay, and then as I said, you want to start with the charge controller. Everybody always says that as soon as they go out to the site, they say the charge controller's failed. But as I said, 90% of the time I find that's not the case. It's something else going on. But nonetheless, you still want to start with the charge controller and with the battery voltage. Because with those two things, you're going to figure out which way to go. Again, as I said earlier, there are a whole bunch of parts of the system. There's the battery, there's the solar module, there's the charge controller, there could be load conditioning equipment, and there's wires that go in between. So you really aren't certain what the issue is when you first get out there. And actually, it could be none of the components. It could be something else. It could be shading that has caused the issue, or the load is too great for the system. But again, where do you start? How do you start by isolating this? Well, the easiest place to start is, again, with the battery voltage and charge controller. Okay, and when you do that, you have to know what type of charge controller you have. One of our earliest webinars that we've done last fall was with regards to charge controller types. And we're just going to kind of briefly go through that again to remind people of that. And for more details, I'd recommend going back to that webinar. But again, in order to know if your charge controller is working correctly, it helps to know what type of charge controller you have and how it functions. So briefly, you've got the shunt regulator, series regulator, pulse width modulated regulator, and MPPT. Okay, a shunt regulator works by shorting the array. That's how it regulates. So if you're reading 0 volts on the array input wires, there's a good chance that the regulator is regulating. Okay, and you can do that by, this goes back to the battery voltage again, confirm the battery voltage is within that regulation window. The shunt regulator is an on-off type, which means the battery will go up to what they call the disconnect voltage, and it will disconnect the array, and when that voltage drops slowly, it'll reconnect it again. Typically, that could be for a 12-volt system, somewhere between 14.1 volts. For the disconnect and the reconnect might be like 13.8 or 13.7, something like that, 13.8. So if your battery voltage is within that window and you're seeing that your array voltage is at 0 volts, then there's a good chance it's regulating. So that's how you would tell if that charge controller is working correctly or not. On a series regulator, the regulator actually kind of functions opposite. It actually regulates by opening the array. Now again, this is also an on-off type, but the difference is so if it opens the array to regulate, then instead of the array voltage being 0, the array voltage is going to be the open circuit voltage. So for a 12-volt system, that voltage should be around 20 to 22 volts. For a 24-volt system, between 40 and 44. So again, if you see your array voltage is that, and your battery voltage is within that window I mentioned earlier, somewhere around 14.1 volts and 13.8, somewhere around there, then your battery is probably in regulation. Pulse width modulator, your PWM regulator, is similar to a series one, except that it's going to be doing that disconnect and reconnect at a high frequency. Okay, so it's doing this kind of pulse, and that's how the pulse width modulation works. So by doing that, it can kind of do a constant voltage to the battery by chopping that array current at a high speed. So, but what that means though is that means then the array can vary anywhere from the battery voltage to the open circuit voltage depending upon the state of the charge of the battery. If the battery is at a low state of charge, then the array is going to be at battery voltage. If you're near a full voltage battery, if you're starting to regulate, and that battery is almost 100% charged, you're going to find that the array should be pretty close to the VOC. However, if you're finding that your array is at 0 volts, then you have another problem. That might show that there's some other issue. There might be a bad wire, a bad module that you have to go track down. Okay, but again, it can vary anywhere between the battery voltage and the open circuit voltage of the array, depending upon where it is and the regulation cycle. And again, part of I say the regulation cycle because again, it's a multi-stage unit. You have a bulk, an absorption, and a float mode to those regulators. An MPPT similarly has multi-stages. It has again a bulk, absorption, and float. But this is a little more difficult to do because the array voltage can vary quite a bit, as that's how it actually functions. Actually, the MPPT is actually changing that array voltage to maximize the current out to the battery because you're trying to get the maximum current to the battery for it to recharge. So in that sense, it's kind of a step-down converter. So the array voltage is always higher than the battery, though, because again, it's a step-down converter, so it's going to vary that array voltage to maximize the current out, but it always has to be higher than the battery voltage, otherwise current's not going to flow. So again, that could be anywhere from basically your battery voltage again on up to open circuit voltage depending upon state of charge of the battery and where the maximum power point is of the array. Okay, one of the easiest ways again to find out how your charge controller is working is the LEDs. All charge controllers have an LED of some form. Some might have more than others. Some might even display that has information on it. But you want to check those. When I get a tech support call, kind of the first two questions I have are, what is the battery voltage and what LEDs are lit on your charge controller? And all of them are important. Different ones might have status LEDs, they might have an LVD LED, they might have a battery status LEDs, so all of those are important. And it can tell you whether the charge controller is in regulation. There might be error codes. It might tell you whether it's an LVD or whether it's charging or not. And the error codes might tell you what's going on. It might tell you there's a short on the load. They might tell you there is a problem with the array. It might tell you that there's some other fatal error. It might tell you of a high temp alarm. So again, looking at those LEDs and again having the manual for the charge controller such that you can look up those error codes while you're there and figure out what they mean, it can be very handy as well. And again, here's an example of some of the things you can find with a Morningstar product, whether it be the SunSaver, ProStar, the TriStar. Again, you can look at these depending upon how they're blinking. You can find out all kinds of information with regards to reverse polarities. Let's see, high temperatures. What else we got there? Shorts on the array or load. all different kinds of information you can get just from those LEDs. So again, going back to the controller, if you find the controller is in LVD and your battery voltage is low, for a 12-volt battery, somewhere between 10.5 and 12.6, then the load's been disconnected. I mean, usually the first way you find out you have a problem with your system is the load's gone down. So you get out there and you might see from the LEDs on your charge controller and from your multimeter, it's saying that yes, the battery is low and that the charge controller disconnected the load to protect the batteries from being over discharged. So that means the system did what it was supposed to do and it was working the way it was supposed to be. So the system hasn't necessarily failed. It's just that it has failed to support the load. Now we have to find out why. And there might be multiple reasons why the LVD has occurred. The two main reasons are either the load was too big for the system or it's not getting enough charge current from the solar array. So let's address those two things. Now, if the load is too great, you're going to want to try to measure the load and reconfirm that it is what the system has been designed for. We've got a whole tech note again on that, understanding your loads, and on system sizing as well, basic system sizing. So you might want to go back and review those. But again, you need to be able to measure the load and confirm that it's within the design parameters. If it's a frequent problem that people change the loads or they add loads to the site, or maybe the load's being used more than expected. You might be pulling something more often for, if you're doing measurements and all of a sudden you're pulling more than normal. These things add to the load of the system, and it may be too much of a burden, and that may be why this has happened. You drain the battery down, so you need to confirm that. And again, otherwise, it would be if the load is within specifications, then you might need to figure out why there wasn't enough charge current going to the batteries. It could be as simple as you've had a bad weather pattern. I saw this happen probably about 8 to 10 years ago in Texas. Texas had some weird thing where they had a whole bunch of storms come into the Gulf, and normally their weather's really good, so most batteries there are only a 5 or 7 day autonomy battery. They had some weird pattern where they literally had clouds and bad weather for 10 to 14 days straight, and I was surprised at how many solar systems went down. It's one of these weird things where no matter what you design for, there is that fluke weather pattern that can happen, your 20-year storms, your 50-year storm type of thing, where it just happened and the loads go down and it is what it is. The only other way to do that is to put in a bigger battery maybe or more solar. So either sometimes you have to, if you've got an absolutely critical load and you can't tolerate that, then you're going to have to increase the size of the system. Otherwise, just tolerate that there may be an unusual weather pattern that has caused this to happen, and hey, it happens every 5, 10, 20 years, whatever. Okay, and the other thing is then to confirm that the array is actually putting out what's supposed to put out. And this is going to bring us back around to the array troubleshooting webinar that I had just done a few weeks ago. So let's go back into the array troubleshooting. Let's just do a quick review of that. There are two basic tests you can do to determine how your array is functioning. One is the open circuit voltage test, and the other one is the short circuit current test. With the open circuit voltage test, you can find several things. These are the common things you can look for. You can look for reverse polarity. You can find open wiring or short circuit wiring. A good example of open wiring was what I showed you earlier, that photo of the wire, literally that was the array output wire right by the MC connector that had failed. Again, somehow that the insulation got damaged and it corroded and it broke apart. Loose wiring, that's another common one, as I mentioned earlier, especially with the thermocycle and the junction boxes. Incorrect array wiring, if you've got multiple solar modules being wired in series and parallel, it's easy for somebody to get the wiring confused. And I've seen that happen before, and let's say you might have 4 solar modules and you may have gotten 2 wired correctly, the other 2 aren't. And what can happen sometimes is that you can run great for the summer when you have extra solar, and then come in the fall when you really need this whole solar array, all of a sudden having half the array not wired correctly starts to fail. So this might be one of those where, hey, it ran great all summer long. We installed it in the spring and it ran great, and then in the fall you had a problem. That's usually when I tell people to double check their array wiring, because that's a common one there. A failed bypass diode. And again, we'll have a new tech note on that coming up, and I think I addressed that in the in more detail in the troubleshooting webinar. And of course, a failed module. If you got an older one, that can happen, or if you've got one that has that's been damaged in some way from the backskin or something like that, then it can fail for those reasons. The short circuit current test, we did not go into a whole lot of detail last time because we did not have enough time. So we're going to go into that in more detail here. A couple of big cautions on that. One is that you are measuring, you're basically short circuiting the solar array. So there's going to be a lot of current going through there. Most solar modules can have a short circuit current of up to almost 10 amps. Some of them now are at 9.2 amps or so. Some of the bigger ones. So we need to make certain that you have equipment that can measure that without damaging it. Again, most multimeters are good up to 10 amps, so you should be fine, but make certain that your multimeter can handle that and that you have your probes and your leads set correctly for that. It's a common problem is people forget to switch the leads between voltage and current measurements, and you could damage your multimeter. Most multimeters have a 10 amp fuse built into them for that reason. But nonetheless, you don't want that to blow out in the field. It's not fun. And to open those back up, you could also void your calibration warranty. So keep that in mind. If you've got to replace that fuse, you may your calibration certification has probably been voided, and you may need to have that recertified again. So again, you want to try not to do that and avoid that problem. And of course, because you have all that current, there's going to be an arc. Because you should be doing this in sunlight. If you're trying to get a good measurement, again, you want to do it under the best sunlight conditions. So when you break that connection, you're going to have a decent voltage plus a high current. So there's going to be an arc associated with that. So you want to be very quick about it. And again, although the VOC test can tell you, the open circuit voltage can tell you many things, there are a few times when the short circuit current test can tell you some stuff. Loose connection is a good one. I had a tech support call probably about 9 months ago or so, where it was a loose connection to junction box. Like I mentioned, it was a 10-year-old, 5-year-old I think system, something like that. And again, the thermal cycling had caused the loose connection. It was reading fine on the VOC test. So what's happening was there was enough of a connection that it was okay to measure the voltage, but the connection wasn't enough. There wasn't enough contact metal there for the current to flow. So when we did the short circuit current test, we found out there was a problem there. So that's one of the things you can find on that. And then we were able to backtrack and find out that it was just, literally, I think it was almost like almost a full turn on that screw in the solar module, and that was it. It was that simple. Unfortunately, the system went down because of that. And again, I'll get back to maintenance. Doing proper preventative maintenance can prevent things like that from happening. As I mentioned before, tests should be done on a sunny day. Again, using, I prefer an inline meter. People asked me before if you could do it with a clamp on probe. The problem is you still need to make that short circuit somehow in order to get that current to flow. So you still need to have a shorting wire for that reason. So I find it just easier to do an inline. The other thing is that if you're working with a smaller solar module or with lower currents, inline meters aren't as accurate. I'm sorry, clamp-on probes aren't that accurate because they're measuring an electromagnetic field around the wire. So they're measuring that field, not the actual current flowing. So they're not as accurate. No matter how good of a clamp-on you have, they can be off by several tenths of an amp or more. And then depending upon what you're trying to measure, that may or may not be an issue. But if you have a small solar module to begin with on a cloudy day or a non-ideal day, then if its maximum short circuit current is only about 2.5 amps, and you have a meter that's only measuring to within a half, that could be off by as much of a half an amp because of the accuracy of it, then that's not so good. So I usually prefer inline meter. Again, it's also the easiest way to do the short circuit. That way you don't have to put an additional wire in there. And again, you would simply just put the positive lead on the inline meter on the module positive terminal and the negative on the negative, and measure that current going through there. And when you're done, make certain you break that connection fast. Again, make certain you have your meter set to current, and make certain you have your leads adjusted for that. And again, because sunlight conditions can vary, it's helpful to have an insulation meter. The measured value will be lineared with the amount of sun you have. So if you're working with 50% sun conditions, then the module output current is going to be 50%. Okay, so you're going to keep that in mind as well. And then generally, if your value is in the 20%, that's probably fine. If you're really 20% of the value, again, there's a lot of things that could be going on that could make that vary, including degradation of the module, which is a little bit of, or you're just not measuring the sunlight hitting the module correctly and things like that. So there could be a lot of error there. So generally, if you're within 20%, you're probably close enough, and that probably means your module is probably fine. Again, let's look at some of the things you can find. Again, no current. Obviously, there could be a open circuit or a loose connection in there. As I mentioned before, it's a common problem with thermocycling. So you just want to fix that problem, whether it's tightening the terminal or replacing the bad connection or wire. Again, I mentioned degradation. Solar modules can degrade by as much as 1% per year. So if you've got a module that's been out there 20 years, it can degrade by 20%. So an 80% might be enough still. I mean, isn't the module's gone bad? I mean, you're still getting 80% out. But depending upon how tightly your system was designed, that degradation may be a problem with supporting the load still. If you don't have an old module, if you have a new module and you're finding that your degradation has occurred, you may want to contact the manufacturer and find out if you have a warranty claim or not. Most of these modules have anywhere between a 10 and 20-year warranty on performance. So if you're finding that you're getting a low current output and you have a relatively new module, one that's 5 years old or something like that, and your output is like 75% or 50% of the rated value, then I would contact the manufacturer and find out why it's degraded that much and see if you have a warranty claim. Batteries. I know I talked earlier about how you can find out if they've gone bad or not. But some of the other, and with the trending and everything else, but some of the other things to look for is if they're old or not. If you've got batteries that are more than 5 years old, that's when you need to start looking at them to determine if they need to be replaced or not. Most good solar batteries and a properly designed system that's been maintained correctly and things like that should last about 5 to 8 years. I mean, it's very common to get 8 years out of them. If you're in a warmer climate like Texas or Arizona where your batteries are seeing a lot of heat, and we'll go into that more. Actually, our next webinar coming up on September 20th, let me go ahead and plug that one. We'll be covering actually its battery basics. So we'll be talking more about the batteries and the heat effects on that. But again, if you're in those climates, then you might find you're only getting 5 years out of it. But again, between 5 and 8 years, depending upon the battery and things like that. If it's less than 5 years and you have a failed battery, if you find you're having issues, it's got reduced capacity, failing to hold the charge, you might, before you put new batteries in and damage a new set of batteries, you might want to find out why those batteries fail prematurely. It could be something as simple as somebody used the wrong setting on the charge controller. Maybe they had it set for, they had too low a voltage setting or too high a voltage setting for regulation. Could be something that simple, maybe something bigger than that. But again, before you put in a brand new set of batteries, you may want to just double check, make certain your system is functioning correctly before you damage a new set and find yourself replacing brand new batteries every few years. Batteries are very expensive. They're about 40% of the cost of the system nowadays, so they're probably one of the single most expensive components. You want to try to get as long a life out of it as possible. And again, we'll go into that more in our next webinar on battery basics. As I mentioned, correct charge controller settings, temperature compensation. Actually, I just helping a customer again recently. They actually had the charge controller in a sealed box with other electronics, and the battery was in a separate box that was vented to ambient temperature, and they were using a charge controller that had temperature compensation, but it was inside a sealed box and not near the battery. They were having to add a remote temp sensor to it. Because they were reading a voltage that was off by quite a bit, actually. It was reading too high. The batteries weren't getting fully charged. It was actually, after they adjusted for temperature, the batteries were being charged by almost a whole volt less than they should have been because it thought everything was too hot. So having proper temperature compensation and measuring that battery temperature correctly is very important. Okay, and lastly, let's get into low conditioning equipment. This is another one where I've had, again, calls where the charge controller has gone bad or the system has failed. As it turns out, it's it's the inverter or converter that's the problem. So we're going to go into that briefly. Just to try to give you an overview on that one, you may need to contact the manufacturers for more detailed troubleshooting on those. But let's just try to get into some of the basic things you can look for and some of the simple things you can do. One of the simplest things is there voltage at the input terminals? If there is, then obviously let's continue on. If there isn't, then go back and find out why. Again, you may have gone into low voltage disconnect that we talked about earlier, something like that. So you need to find out why there is no voltage it could be a circuit breaker trip for some odd reason. Maybe the inverter had some type of surge on it that overloaded the breaker, tripped it. So you might want to go back and troubleshoot and find out why there's no voltage at the input terminals to the converter or inverter. Also, a lot of the inverters, not so many of the DC-DC converters, but a lot of the inverters have a built-in low voltage disconnect. So you also might want to confirm that. If you do have voltage on the input, you might want to check and look at the LEDs and arrow lights on the inverter or converter and see if it's telling you that it might be a low voltage disconnect. You would also go back to that battery voltage measurement and see if the batteries are inside that LVD window for that inverter or converter. Okay, another common one is short circuit or an overload on the load wires. Just like you can find on the solar array, you can find that there could be an overload or a short somewhere. Maybe two wires got caught together, who knows? And generally, most of the converters or inverters have an overload protection that shuts down in a overload or short circuit situation. So you might want to check for that. Some of them have a low power shutdown. I've actually had this problem a lot with inverters recently. You might have a load that's as little as, I don't know, 5 or 10 watts, and you might have on some of these inverters, they have a what they call an idle mode, a low power shutdown, such that if your load is less than a certain value, like I said, it could be as little as 10 or 15 watts, then it thinks there's no load and it goes into idle mode so that it reduces its parasitic load on the system. So if you have a small load, you might have that as a problem. You might need to disable that feature. Thermal shutdown, that's another one as well. That's a big problem with both inverters and converters, especially if they've been placed in a sealed enclosure and don't have proper ventilation or something out, or proper heat sinking on a converter maybe. So again, you might want to check for that. And there might be error codes or LEDs on that device that might tell you that. And lastly, always contact the manufacturer for additional troubleshooting assistance, or check the manual. The manual might have some troubleshooting instructions in it, so you might want to check that as well. Okay, again, I know I've plugged our TechNotes webinars quite a bit. Again, there's lots of great resources and additional information on shading, on array troubleshooting, and things like that up on our website, so feel free to look at those. Again, I think a couple of those are in the handouts. And again, our next upcoming webinar is going to be on September 20th on battery basics. We'll go into some more of those things I mentioned earlier on those. It's going to be, it's pretty much about 4 weeks from now, and that's because Solar Power International, SPI, is happening in 3 weeks. That's September 10th through 13th in Las Vegas. So I know a lot of people are going to go to that one, so we were going to schedule it for that week, but then we realized that a lot of people will be out, so we're going to schedule it the week after instead, so people have an opportunity to make it to the webinar live and not have to look at the recording. Okay, and I guess we have about 10 minutes for questions. So let's see, Errol, what questions do we have?
Yeah, so we actually got the same question from 2 people that wanted to have us speak a little bit on the capabilities of traditional battery load testers and how and to what degree the information it provides might be relevant or applicable to the off-grid renewable system world.
Oh, that's a great question. And again, not an easy answer. It depends on the load test equipment. Generally, again, you have to take the batteries out of service to do this. You can't do it with a charge on it or with the load connected, so you have to take it out of service again, which may or may not be a problem for those. And again, it depends on the tester. It really does. So I have some of them might be good, some of them might not be. Most of those are geared towards the automotive industry, so they're geared towards more of a cold cranking amps test and not so much a capacity test. So again, it depends on the test device, how it works, whether it's measuring impedance and things like that. So that's a tough one. To be honest, I really have a hard time answering that because it depends on so many things, specifically the type of tester and things like that. Okay. Sorry, I know it's probably not a
All right.
great answer, but it's a tough one. So next question.
All right. Yeah. Well, currently we've got an open slate right now, so if anybody wants to type in questions in the chat box, feel free to do so.
Okay, we'll give people a few more minutes to see if they have any questions. I'm not really sitting outside with you, Errol.
Nope, not sure there are any questions. Remember that you can always email us or call or submit a contact form on our website. If you want to circle back on anything, if you want to rewatch it once it's posted on our website, if questions come up, feel free to send those towards us, and Rob and I will help answer.
Okay, well, thank you all again. Again, if you got any other... Oh.
Rob, I guess we got one more,
okay.
And this is a good question. Basically, and I'm familiar with, I think Outback does this and a few other people, but carbon additions to traditional VRLA batteries and how that carbon addition changes performance.
Good question. Actually, a lot of manufacturers have been doing that. I think that technology's been around for about 5 to 10 years now. I know MK's Deca Batteries also has a version of that now as well as Outback. I know Narada batteries have that. A lot of the manufacturers do. And actually, maybe I'll address this in the next webinar a little bit more detail. But what it does is actually it helps the performance in the sense that if your battery doesn't get to a full charge regularly, it'll help eliminate some of the sulfations. On a regular lead acid battery, whether it be valve regulated or flooded, the batteries don't get a full state of charge. Then sulfate crystals can build up on the plates, and they can become permanent if they sit there a long time. In a flooded battery, you can actually equalize the battery and stir up the electrolyte and knock those crystals off the plate to some extent. But if you equalize a valve regulated battery and that battery gases, which is what happens during that process, you can always add water back into a wet battery, but you can't do that to a valve regulated. Again, once that gas is gone, then the capacity is reduced anyway. So if you sulfate a valve regulated battery, then it's pretty much done. So that being said, by adding carbon to the plates, they're finding out that these batteries are more tolerant to what we call a deficit charge mode. In other words, the batteries don't get to a full state of charge regularly. So if you're in a situation where that happens sometimes, those batteries can be very helpful for that. So I don't know that it really necessarily helps their performance in terms of cycle life, or some of that can actually help with temperature a little bit as well. But in general, the big thing it does is it helps, and again, it also depends upon the technology and how they've implemented it and stuff like that. But primarily what it does is it helps with this deficit charge situation where these batteries sit at a low state of the charge for an extended period of time, and these sulfate crystals end up forming and having reduced capacity of the battery. So it really does help with that, and that's primarily what it does and how it can help with that. So I'm sorry, that's kind of a long answer, but I think it helps if you understand a little bit how they work and why it works that way.
All right. I'm not sure I understand his next question correctly. Maybe you'll get this, Rob. He says, suggestions for battery health when wintering over at a seasonal use site. Some suggests to include a small load.
Oh, great question. Actually, we do have that sometimes. You might have a camp or hunting grounds or stuff like that where they're only using the stuff for part of the year and then they shut it down for the rest of the year. That's a great question. Some people talk about literally just taking the battery out of the system and taking it back someplace and putting on a float charger. I don't think you need to do that. Generally, I always tell people, don't put a small load on it. Actually, I tell people the opposite. Just turn the load off completely. If you've got a good charge controller it should just be able to float the battery and just leave it fully charged. So that's a good question. We do get that occasionally. I do see that. And again, I would not put a small load on it unless you're, most charge controllers, again, whether it's a PWM or an MPPT or any of the other ones, generally it's going to go ahead and just go into a float mode. I would actually recommend that. I would recommend not using necessarily one of the on-off type of charge regulators, not the Shawn of the series, but if you've got a good PWM or MPPT, it's going to go into the float mode and it's just going to kind of sit there, and that's going to be just fine. It's better just to float those batteries where they are, not have to worry about pulling them out, putting them back in, and everything else. I just turn the load off and leave it. Let the solar array trickle charge it.
All right, perfect. Thank you very much, Rob. Great question. All right, I guess give people a couple more minutes till the end of the hour if anybody else thinks of something.
Okay, again, our next webinar is going to be on battery basics. That's going to be on September 20th. And after that one in October, not quite done with it yet. We haven't set a date, but the next one after that is going to be on electrical basics. Going to talk about what is a watt and an amp, the difference between power versus energy, single phase and three phase, as well as split phase, which is actually 12240, AC versus DC, all of those electrical basics types of things. We're going to talk about that in some great detail, and I think it should be pretty good. I actually had to laugh. I had to break out and crack open one of my old actually electrical engineering books to try to pull up some definitions and help out on that one. And I don't think, again, I think it's going to be pretty good because I think it's going to cover some of these things, how some things work and things like that. Again, talk a little bit about just some things like basic stuff like all of the current coming into a point, out of a point have to be equal type of thing, things like that. That can really be helpful, again, for troubleshooting. Understanding some of these basics can also help with troubleshooting. So we're going to go into that. And that one, again, that'll be sometime in October. We haven't scheduled the date yet, but just to give you a heads up on our next few webinars. So,
yep. And
okay.
you can go to our webinars page to find the registration links for those once they're announced officially.
Yep, thank you. Okay, thank you again, everybody. I hope you enjoyed today's webinar. And again, if you got any other questions, feel free to contact us by email or phone. And look for this webinar and other ones up on our website. Thank you again.
Thanks, everybody.